Hello and welcome to Fundamental Counting Principle Part 2. And I've set up an exciting example. It's exciting because you have 4 math books and 3 chem books. And what you want to do is you want to set them on your bookshelf and you want to keep each set together. So you want to keep your 4 math books together and you want to keep the 3 chem books together. And you want to know how many different arrangements you could make. What an exciting question this is. So let's start off with the math books and just say, well, how many ways could I arrange these 4 books? Well, for the first book, there would be 4 choices. And then for the second spot, there would only be 3 books to choose from. And then the third spot, there would be 2 books to choose from. And finally, there's only 1 book to remain. Then you have to arrange your chem books. So there are 3 possible ways to choose your first chem book, and then 2, and then 1. And of course we would take the arrangements for the math books and multiply that by the number of arrangements for the chem books. Now there's one more thing that I can do. I can take all of these arrangements and I got to times it by 2. Now why would I have to double this? Well, because we assumed you go math and then chem, but what if I put the chem books first and then the math books? I'm going to get basically another set of arrangements, right? But in this case, it does count as a different arrangement because it's got the chem books first and then the math books. So in order to compensate for this possibility down here, that's why I have times by 2. So if I multiply this mess together, there are 288 arrangements possible. Okay? So again, in the big picture, we figured out how many arrangements there are of the math books, how many arrangements of the chem books, and then we went, oh wait, we could have started with chem and then math, so that's why we have to double the numbers that we get. And that is my first example done. What a neat example that was. Okay. Now we're going on a trip for my second and last example of the day. We are traveling from point A to point B and then to point C. So this is the travel question. All right, so we're on a little trip and then back. So we've traveled from points A to B to C, and then we're going to go and then back again. Okay, but to make our little trip scenic, no route can be used twice. No route can be used twice. Okay, and that makes sure it's very scenic for this little trip. So now the question is, how many routes are possible? How many routes exist? Now that doesn't mean they're all going to be fun and you know, scene worthy, but just asking a question, how many routes exist? So here's what you got to picture. Oh, I didn't say how many. Okay, sorry, you're missing information. Okay, so yeah, from A to B, we have a choice of 3 routes. So to get from A to B, there are 3 roads, and from B to C or C back to B, there are 4 routes. All right, so that's kind of important to know, yes. All right, so there we have our complete information now. So here's what you got to picture. First part of your journey is you're going to go from A to B. How many choices you got? Well, you got 3 choices. Actually, I'm going to write this underneath. It'll be easier. Okay, so got 3 choices, followed by, we're traveling now from B to C. And so, okay, how many choices? Oh, I got 4 roads to choose from. Perfect. Okay, now I'm going to continue because I got to go back from C to B. But wait, no route can be used twice. So how many choices do I have on my return trip? 1 less than on the way there. So if this was 4, now I only have 3 to choose from. And then from B to A, well, there were 3, now no, I got one less than that, only 2. So if I multiply this mess together, I get 72 different routes. So that's kind of cool. That's actually a lot more choices than you might think for traveling. And with that, I am going to stop. We will catch you later.